All right, guys, welcome back. So in this video, I'm going to show you how to do separation of variables when you have an initial condition. So what this is basically going to do is allow us to solve for the C and figure out what the C is. So let me give an example of the type of problem here. I'm going to tell you, for example, that dy dx equals 2xy squared. And I'm going to tell you that y of 1 is equal to 2. So this is a point. This is your initial condition. It's a point that's given to you. And given that in mind, we're going to try and find the particular solution here by separation of variables. So when you see this phrase, this idea of like find the particular solution, what that means is, just like we're doing, we're going to find an equation for y, except now we're going to be able to find the particular one that has this initial condition of the point 1, 2. So that's the strategy of what we're going to be doing. Now, the strategy today is that we're still going to do the same thing as the last one. We're going to separate the variables, we're going to integrate, and then we're going to solve for y. Like, we're going to walk through these exact same steps as we go through this problem. Okay, so let's separate this guy. All right, so we begin with dy dx equals 2xy squared. We'll divide the y squared, we'll multiply the dx. So we separate it, check. Now let's integrate. Okay, so we'll whip this with our integral stick on both sides. So on the left side, we have integral y to the negative 2, so that's negative y to the negative 1. On the right side, we get x squared plus c. Now, check. Here's the new thing I want to remind you to do. You can solve for the plus c at any point in the problem, but this is the easiest possible time to solve for it because it's by itself. So right after you integrate, what you want to do is you're going to plug in that point, plug in that 1, 2, and then solve for c. So you're going to plug in the 1, 2. So negative 1 over 2 equals 1 squared plus c. So subtract the 1, negative 3/2 equals c. So that's going to tell us, okay, now I'm going to put that back in. So now I have negative 1 over y equals x squared minus 3/2. Okay, so that's the best thing. I separated the variables, I integrated. But again, this is my new part today. And the new part was to put that 1, 2 in. And they're always going to give you a point on these when x is 1, y is 2, that you can plug in and solve for c. Now, my third step, of course, is just to solve for y. So that should be pretty straightforward. So we'll multiply the y to both sides. So negative 1 equals y times x squared minus 3/2. So my y is negative 1 over x squared minus 3/2. And you could simplify, but who cares? So notice the new bit here, right? Because we've gone ahead and done this, this idea of solving for c, there's no c in our answer. So what this is, by the way, this is a solution curve. So this is an equation for the solution curve, and actually that goes through the point 1, 2. So if you were to sketch the slope field and draw a solution curve through 1, 2, this is what the equation of that curve would be. Beautiful. Okay, so again, the only new thing here was right after we integrated, we just went ahead and solved for c. All right, let's do a couple more examples so we can see a few more. So now suppose we have this. Suppose we have dy dx equals e to the negative x plus 2 divided by y. So we'll multiply. Okay, so y dy equals e to the negative x plus 2 dx. All right, so we separate. Now we integrate both sides here. All right, so we're going to get y squared over 2 equals. All right, on an integral like this, you want to split it up. So integrating 2, of course, that's going to be 2x. When you integrate e to the negative x, I know a lot of you guys can do this in your head, but always good to do u sub, right? So, okay, u equals negative x. The du is a negative dx. So we do a negative and a negative. So that's just a negative integral e to the u. So that's a negative e to the u. So that's negative e to the negative x plus c. Okay, this is the point where I also recognize that I didn't actually tell you all the information in the problem. I meant to also tell you guys to find the solution y equals f of x with the point f of 0 equals negative 4. Okay. So there's your initial condition right here, that 0, negative 4. So that's what I need to do at this point in the game. I need to plug in 0, negative 4. Okay, so that's the point here. And also, when they say find the solution, they mean find the particular solution. You need to find y. That's what you're doing with most differential equations. You're finding y. So now I plug in x is 0, y is negative 4. I'm going to get 16 over 2, that's 8, equals negative e to the 0 plus c. Okay, so that's 8 equals negative 1 plus c. Great, so c is 9. Okay, so that means y squared over 2 equals negative e to the negative x plus 2x plus 9. All right, let's do some math here. Let's multiply by the 2 to everything. So we'll get y squared equals negative 2e to the negative x plus 4x plus 18. Now at this point, I need to solve for y. Okay, how do I get rid of the squared? I take a square root. So now y is plus or minus square root negative 2e to the negative x plus 4x plus 18. Okay, now at this point in time, you might think we're done, but we're actually not. We can find out whether it's a positive or negative. We can find out whether it's a we can find out whether it is a plus or minus by plugging in the initial condition again. So we're going to plug in that point, that 0, negative 4, a second time. Now, I know it seems weird that we're plugging in a second time, but the first one was to find the c, and the next one, we're trying to solve for the plus or minus here. So once I'm at this point, I'm going to plug this in again. So I'm going to get negative 4 equals plus or minus square root negative 2 plus 18. So I get negative 4 equals plus or minus square root 16. So I get negative 4 equals plus or minus 4. Well, now you have to do the really hard step of figuring out which one is it. So once I plug this in, well, let's see. Does negative 4 equal positive 4? Or does negative 4 equal negative 4? Well, I'm assuming you have a brain, so you know that negative 4 is equal to negative 4. And what that means is we just want the negative. That means we want the negative here, we want the negative here. So that tells me that the final equation we have is the same thing, it's just going to have a negative. So y would be negative square root negative 2e to the negative x plus 4x plus 18. Okay, so this problem is going through the same strategy, but again, as we did this here, we ended up with an extra negative in here, a plus or minus, and then we just had to plug in that 0, negative 4 again to help us figure out whether it was plus or minus. And this will happen every time you have a plus or minus. You're always going to do this. You're just going to plug in the initial condition, the IC, again. Okay, one more brief example that I wanted to go with. So let's say we have this dy dx, and this one's going to be tricky with a lot of minus signs in it. 320 minus y, and I'm going to tell you y of 2 equals 19. Find the particular solution. Well, anytime someone asks you to find a solution to a differential equation, you're going to need to go ahead and do separation of variables. When it says find the solution, that's your technique or your reminder to use the technique of separation of variables. Okay, so dy over 20 minus y equals 3 dx. Again, there's no x, ain't no thing, and I'll show them when we integrate. So we'll hit both sides with our integral stick. The right side's easy. The left side, we have a little u sub to do here. Because u is 20 minus y. The derivative of that is a negative dy. So we got a negative and a negative. So it becomes negative integral 1 over u du. So negative ln u. So negative ln 20 minus y equals 3x plus c. Okay, cool. So let's see. We separated. We integrated. Now before we solve, we just kind of do the step 2b. We're going to plug in the 2, 19 to find out what c is. Okay, so I'm going to do this. So negative ln 20 minus 19 is natural log of 1 equals 6 plus c. Now the natural log of 1 you know is 0, so c equals negative 6 because that's 0. Okay, so that tells me negative ln of 20 minus y equals 3x minus 6. Okay, now the steps you need to do this, right? Remember, our goal is to solve for y. Like, that's what we want to do. But we have to unpack this along the way. So we have to deal with a minus in front. This one right here. And then we're going to deal with the ln. And then we're going to have to deal with the absolute value. That's kind of the order we're working with. Okay, the negative should be easy. So ln of 20 minus y in absolute value. Don't drop the absolute value. It's crucial here, as you'll see. It's 3x minus 6. Now, what's the opposite of ln? Well, you did well in the last test. You know that e and ln are opposites. So those will cancel out. So I'm just going to get absolute 20 minus y equals e to the 3x minus 6. Okay, so now the absolute value we know leads to a plus or minus. We talked about that earlier in the week. So 20 minus y equals plus or minus e to the 3x minus 6. Now, you can do this later, but just like with the plus c, I would encourage you to plug in the 2,19 here to find out whether it's positive or negative. So right now, I'm going to try and solve for the plus or minus. So x is 2, y is 19. So I get 20 minus 19 equals plus or minus e to the 6 minus 6. So I get 1 equals plus or minus e to the 0. So 1 equals plus or minus 1. I think we would like the positive. So that's why I do it here. I do it right away because now I don't have to deal with a plus or minus. I could just write 20 minus y equals positive e to the 3x minus 6. And that just makes solving for y a lot easier. So again, I'm going to solve for the plus or minus ASAP. Just to help me simplify things. Now my final goal is solve for y, so I'll add that, subtract, so I'll get y equals 20 minus e to the 3x minus 6. Okay, cool. So that's our particular solution. Again, that's the one we plugged in the 2,19, and it helped us find c, but it also helped us find out whether it was a plus or minus, which appeared because of the absolute value in ln. So this was a long problem. We had to separate, we integrated, and we had to do a lot of work to solve for y. But the important steps really here are separating, integrating, and then finding this c value. Those are the things we want to focus on as we get to our final answer. Okay, thanks for watching. Hope this helped, and I'll see you guys soon.